Okay, today we're going to go over the review that hopefully you have completed. As I'm going through this and as Ms. McFall is going through it, you are allowed to stop the video anytime you want to stop and fix your answers, or if you hadn't written anything, you need to be sure you stop and write down how you got your answer. So let's look at number 1 first. What I'm going to use is my problem-solving strategies to make sure I'm solving this correctly. Sue's mother made 75 cookies. She put the cookies in bags with 3 cookies in each bag. How many bags could she fill up? Solve using grid paper. Well, the question is, how many bags could she fill up? I know my total, and I know how many groups I'm doing, so this sounds like it's a division problem to me. The problem is 75 cookies divided by 3. If I'm solving division with a grid paper, the first thing I want to think to myself is how many groups am I putting this into? I'm putting it into 3 groups. So next to my rows, 1, 2, 3. This is going to help me stay organized. I'm starting with 75 cookies. So next I need to think to myself, would I be able to put a rod into each of my groups? The answer is yes, because if I put 1 rod in each group, I'm only taking away 30. So I'm going to shade in a rod for group 1, a rod for group 2, and a rod for group 3. That would get me a total of 10, 20, 30. So I need to subtract and see how many cookies I still have left. I still have 45 cookies left. That means I can still put another rod in each group. 10, 20, 30. And then I need to subtract to see how much I still have. 45 minus 30 is 15. So now I'm thinking to myself, how many could I put into each group now? I don't have enough to put 10 in each group, so I can't put a rod. I'm down to units. 3 times what would get me 15? 3 times 5. So I would put 5 units in each group. 5, 10, 15. 15 minus 15 is 0. So now I'm going to look. In group 1, I have 10, 20, 21, 22, 23, 24, 25. So that means that 75 divided by 3 equals 25. I might want to check that using the box method. 20 plus 5 times 3. 3 times 20 is 60. 3 times 5 is 15. 60 plus 15 is 75. That's how I know I got my answer correct. Let's look at number 2. You are reading a book with 132 pages. If you want to read the same number of pages each night, how many would you have to read each night to finish in 4 days? I need to figure out how many pages I'm reading each night. I'm starting with 132, and I want to finish it in 4 days. This sounds like another division problem to me. It says to solve using the big 7. So I would start by setting it up. I know my total is 132, and I know I'm dividing it by 4. So I'm thinking to myself, 4 times what will get me close to 132? I know that 4 times 30 is 120. And I would have 12 still remaining. And so I'm thinking 4 times what would get me closest to 12? 4 times 3 would get me exactly 12. So I've got 0 left. 30 plus 3 is 33. So I need to check this using multiplication. My answer, 33 times the number of groups, 4, I should get 132. So let's use the box method. 30 plus 3 times 4. 4 times 30 is 120. 4 times 3 is 12. 120 plus 12 is 132. Just what I thought it should be. Now, if you're still struggling on these, Miss McFall and Miss Forsong do have anchor charts up on the wall. You need to be sure and go look at the anchor charts if these two problems are still tricking you. Let's move on to number 3. Number 3 says, Jeremiah had 13 party bags for his classmates. Each bag contained 15 pieces of candy. Using an area model, show how many total pieces of candy Jeremiah had for his classmates. Use the base 10 paper to represent and solve your problem. So I know he has 13 party bags. Each bag has 15 pieces of candy. And I want to know how many total pieces of candy Jeremiah had for his classmates. This time I don't know the total. That's what I'm trying to solve. This sounds like a multiplication problem to me. I'm going to solve it using the grid paper. The first thing I know is that I have 13 groups. So I'm going to put 10, 11, 12, 13 down the side because that's how many groups I'm creating. That's 10 plus 3 in expanded form. The next thing I know is that each of my groups is going to have 15 pieces of candy. So that means group 1 has 10, 11, 12, 13, 14, 15. That's 10 plus 5 in expanded form. If my first group has 15, my second group must have 15. My third group must have 15, all the way down until I've filled 13 groups of 15. I know they all have 15, and I need to fill it all the way to 13. When you're doing this, you should be seeing that this looks a lot like the box method to you. You've put your numbers in expanded form, and now you're just finding out how many were in each group. 10 groups of 10 is 100. 10 groups of 5 is 50. 3 groups of 10 is 30. 3 groups of 5 is 15. And just like in the box method, you'll notice that your biggest numbers in your biggest box, your smallest numbers in your smallest box down here. Now you need to add them all together. 100 plus 50 is 150. 30 plus 15 is 45. I have a total of 195 pieces of candy. Let's look at number 4. David is organizing his favorite books on a bookshelf in his bedroom. He can fit 23 books on each shelf, and there are 17 shelves in total on his bookshelf. If David plans to fill his entire bookshelf with all of his favorite books, how many books can he place on the shelves? Again, I don't know my total. I just know how many shelves I have and how many books he can put on each shelf. This sounds like a multiplication problem to me. I know I can put 23 books on each shelf, and there's a total of 17 shelves. So my problem is 23 times 17. My most efficient strategy is to use the box method 23 times 17. 20 plus 3 times 10 plus 7. 10 groups of 20 is 200. 10 groups of 3 is 30. 7 groups of 20 is 140. 7 groups of 3 is 21. Add together all of your partial products. 200 plus 30 is 230. 140 plus 21 is 161. Put it together, and you have 391 total books he can place on each of the shelves. Again, Miss McFall and Miss Forsong have an anchor chart for the shading strategy and for the box method. If you're unsure how to do it, you need to go check those two anchor charts. All right, let's move on to number 5.
Okay, number 5 is a table question. The table below shows the relationship between the number of green triangles and the total number of blocks in different designs. So I see total number of blocks and number of green triangles. And I see my numbers, the bigger numbers on top, smaller numbers on the bottom. If the number of total blocks is 48, what is one way to find the number of green triangles in that design? So I need to figure out what the pattern is in this table. I know that I have 48 total blocks, so I'm going to extend my table. 48. And here's my question. I don't know how many number of green triangles there are. This is my input, this is my output. So I'm going input to output. So I need to decide, how am I going to get that? From a bigger to a smaller, I'm either going to subtract or divide. Those are the only way I'll get smaller options. So when I come down here and look, the only two options are C and D, to go from a bigger to a smaller. So I'm crossing those out, A and B. The number of green triangles, this one equals the total number of blocks minus 6. Well, if I come back and take that and I look at these numbers, and if I subtract 6 from 66, I'm not going to get 11. So I know that can't be right. The number of green triangles equals the total number of blocks divided by 6. Well, if I come here and look, 66 divided by 6 equals 11. So this would be my answer, the rule of the pattern to this table.